All right, ladies and gentlemen, we're going to talk about how can I prove or show that two triangles are similar. So the first thing we need to understand is what makes two triangles similar. And if you look, we have two criteria here that makes two triangles similar. We call these the properties of similar figures. They also hold true for triangles, okay? So the first property we need to have is that corresponding angles are congruent. Remember, corresponding means matching. So we're going to match angles, show that they are congruent. The other property we have is that corresponding sides are proportional. Okay, so to kind of refresh your memory, proportional means when you have two ratios equal to each other. So if you recall, we would match sides, turn them into fractions, and check if the fractions are actually equal. Okay? So this is how to prove similar figures. Figures are any type of polygon, any shape. Okay? What we're going to focus on today is we want to prove that triangles are similar. And to do that, the math really doesn't change. We still have to kind of match angles together. We still have to match up fractions and make sure they're equal. But what happens now, because we're dealing with triangles, we have some shortcuts we can use. So if you look at 2, 3, and 4, these are postulates and theorems, but I want you to think of them as shortcuts, okay? So think of all these guys here that I'm highlighting. These guys are going to be our shortcuts. All right, we're still doing the same math, but now we have to do less work. So our first shortcut is called angle similarity postulate. And what this says is to show that two triangles are similar, all we have to do is match angles. So for example, angle A and angle A prime. Match the angles and make sure that angle is congruent. So we have one set of angles congruent. And the last thing you have to do is check if another set of angles are congruent. So in this postulate, we don't even have to check the sides for fractions. Okay, we don't have to find the scale factor. We just match angles, and we only need two sets. Okay, so to summarize this, all we need is two sets of congruent angles. Sides do not matter in this case. If we can show two sets of congruent angles, then we can say these two triangles are similar. Okay? Our other shortcut is called side-side-side similarity theorem. And what's great about this is we now don't care about the angles. What we want to do is make sure our sides create the same fraction. So if our sides create the scale factor, if we match up sides and they equal all the same fraction, we do not have to check the angles. Okay? All we have to do is match side to side, check if it equals the same fraction, check the next side and the next side. So we have to match three sides together and check if they are the same fraction. So real quick, just to bounce through this, AB, if we knew the measure, AB would match with PQ. Okay, and we would check to see what fraction that would make. Then we'd go to the next side. BC would match with PR. And then we would check, do these two fractions equal the same fraction? If they do, we would then check our third side, which was CA and it would match with QR, okay? If all three of these fractions equal to each other, then we can say these two triangles are similar, and we can write the similarity statement of PQR. So again, in this one, we just need all three sides to be proportional. So create the same fraction. And this shortcut, we don't care about the angles. Last but not least, our last shortcut is called side angle side similarity theorem. And in essence, this theorem is a combination of the two above. So in this one, we need two sides to be proportional, and we need an angle to be congruent. So one angle and two sides. The key to this, though, is the angle that is congruent has to fit in between the two sides that are proportional. So I'm going to use some color to highlight what I'm talking about. So to use this, we first want to find an angle congruent. So if you look, angle X and angle M would be congruent based on what we see there. And now, since we have those angles, to use side angle side, we want to match this side with this side and check if they have the same fraction as this side and this side. And what you should notice is because we have angles here, our sides that we are matching have to surround our angle. If you look, our sides surround our angle. That's why it's called side angle side. Side angle side. So in other words, we would have to say ZX would match with PM, and we would create a fraction. And then we would say, okay, since that is a certain fraction, it needs to match our other side that's around the angle, and that is XY with MN. If these two guys are the same fraction, they equal each other, then we can say these two triangles are similar, and the reason is side angle side. So MNP. Okay, so these are shortcuts. We're going to practice them and go from there. Before we do some examples, I just want to make sure we summarize all of these. Again, I summarized this. Angle is just we need two sets of congruent angles. Okay. Side is we need three sets of proportional sides. So in essence, you're going to need three fractions that all equal each other. And then our last shortcut is one set of congruent angles and two sets of proportional sides. All right, guys, let's do some examples. We're going to do example A. As a reminder, we have shortcuts we can use. First shortcut is angle. Second shortcut we could try is side. And the third one is side angle side. So let's look at example A and kind of come up with a plan. If you look at the two triangles we're trying to prove similar, if you notice, we do not know anything about their sides. We don't know their measurements. Okay? We don't know if they're congruent, nothing like that. So that tells me right off the bat that probably we cannot use side shortcut, or we cannot use side angle side, because these involve sides. What I'm going to try to use is angle, because if you notice in example A, I have angle measures. So I can try to match angle measures and see if we are congruent. So to do that, let's go ahead and start. The first thing I notice is that angle B and angle E are matching, and they also are congruent. So I can say angle B and angle E are matching and congruent because of the arcs. So if you think about this, on a little side note, I have one angle set congruent. To use the shortcut angle, I need one more angle set. So let's look at our angle measures. Angle A and F are not congruent because they obviously have different measures, but I want to see, can angle A be congruent to angle D? So I have to figure out, can I figure out angle D? And the answer is yes, you can figure out angle D by doing the triangle sum theorem, which says I'm going to add all these triangles up, or all these angles up, and put them equal to 180. So we're going to go 92 plus 41 plus angle D should equal to 180. And our goal is to solve for angle D. So 92 plus 41, that's going to give me 133 plus angle D equal to 180. And now we are going to subtract 133 from both sides. And angle D is going to equal 47. So I'm going to put this measurement in. That's 47. And again, we were trying to match angle A with D. And what you'll notice is that they are not congruent. Okay? So because angle A does not match either angle, then we do not have enough information to use the angle shortcut. We only had one set of angles. We're missing another set, and therefore this is not similar. There's not enough information, or the information we have is not good enough. Again, some of you might be wondering why don't we look for angle C? If you look for angle C, you can do that, but you'll be wasting your time because it will also not match and be congruent. Again, 57 would have to match one of these, and it doesn't. All right, so that's how we do angle, or example A. Let's move on to example B. I'm going to go ahead and redraw these guys apart. Label my sides. I have L, P, N, M, O, N. Okay, and then we also have that angle L and angle M are congruent. So again, looking at our shortcuts, our plan is to use one of these shortcuts based on what I'm given. I'm given an angle, and I really don't know anything about the sides. So I can kind of almost guarantee we're not going to use shortcut 2, side, or shortcut 3, side, angle, side. So I'm going to try to use angle. So first thing I want to write down is I know angle L and angle M are matching and congruent. So angle L is congruent to angle M. And again, just a little side note here. This is one angle congruent. Now I'm trying to look for a second angle congruent. So if you look, P matches with O. Is there anything saying that P and O can be congruent? The answer is no. But if you look at my other angle, N matches with N. And that should be a telltale sign, because N, if you look, they are actually the same angle. They are on top of each other. So N has to be congruent to N. And this is by reflexive property, if you recall. So I can actually say angle N in the big triangle is the same angle N in the little triangle, which allows me to get another angle set. So I'm going to mark that in my drawing. Angle N is congruent to angle N, because you notice they're the same angle here. So again, I have two angle sets. I can now say these two triangles are similar by angle. So I would write triangle LPN is similar to triangle MON. And the shortcut I used was angle similarity. Okay. So go ahead and try example C. I'm going to work out example C. I'm not really going to explain it just for lack of time. And then we're going to try angle D together. Okay, actually changed my mind. We're going to work out angle C, or example C. First thing I did was separate them. So if you can see, I have M and P for the top. And then I flipped this triangle around and kind of matched the letters with these letters. So R was at the bottom, now I put it at the top. M is over here. Q is over here. So kind of think of flipping this over. So now I'm going to put some measurements. The first thing I notice is the angles marks. So angle M here is actually the same angle M here. Okay. Now I'm going to put the measurements M to N. So M to N I know is 4. And then I also know R to M, which is this, is 6. I also know from M to P, so M to P, that's going to be 8. And from M all the way to Q is going to be 8 plus 4. So again, from M to Q is M to P is 8 plus 4 more. That gives me 12. Okay, so we have these two triangles, and my goal is to try to see what shortcut will I try to use to show these two triangles congruent. So if we look at a shortcuts, I'm probably not going to use angle because I really only know one angle. Side probably is out of the question because I only know 2 sets of sides. So my plan is to use side angle sides, because I have two sets of sides. I have 4 with 6, 8 with 12. That's for the side and the side. And I also know the angle between them is congruent. And that's one of the shortcuts we need. We need the angle to be in the middle of the sides that we know the measurements of. All we have to do now is prove this. So let's do it. I automatically know angle M is congruent to angle M. And we know that is one angle. So think about, you took care of the middle angle here. Now we're going to take the sides around it. So I'm going to take 4, match it with 6. All right, so now we got to test the sides. So we're going MN over MR, and that's going to give me 4 over 6. I can reduce that, and that gives me, I reduce by 2, that gives me 2 thirds. Okay, so we'll color code this in red. So we did this side with that side. Now what we got to check is, are these sides the same fraction? So let's try it. We'll just do the work here. So MP matches with MQ. MP is 8. MQ is 12. I can reduce by 4, and that's going to give me 2 thirds. So if you look, the two sides that surround it, they actually have the same fraction, which makes them proportional. So if you think about it, I have side, angle, side. So therefore, these two triangles are similar, and the reason behind this is side, angle, side. Let's put that in. We'll put our answer in green. So triangle, this is similarity statement, MNP is similar to triangle MRQ. And this is by side, angle, side. Okay, that's example C. Let's jump down to example D. Again, have a plan. Which shortcut should we use? Well, since we know all three sides, I'm going to do the one with all three sides. All I got to do is start matching. The best way to match in this case, because these triangles are all flipped around, is we're going to match short side with short side, medium side with medium side, long side with long side. So let's try this. Let's go short side. We'll start with this. We'll color code these. So I'm going to go short side over here is RS over WV. That's its short side. It's actually VW. We want to keep everything matching. And that's going to give me 4 over 6. If you reduce 4 over 6, we could reduce by 2. That actually turns into 2 thirds. So now I got to check, does the medium sides give me 2 thirds? So let's change colors. Let's go blue. So the medium sides are going to be QR. And QR matches with the other medium side, which is TV. So let's check this out. QR is 8. TV is 12. I can reduce by 4 in this case. So that's going to give me 2 thirds as well. So far, the fractions match. So these are proportional. I just got to make sure the last one's proportional. We'll do this in purple. So the last side, the longest side is QS and TW. So QS over TW. QS is 10. TW is 15. We can reduce by 5 in this case. So if reduced by 5, that gives me 2 thirds. So if you look, we have 3 sets of sides that equal the same fraction. This qualifies for SSS. So I'm going to write the similarity statement. I can now say that triangle QRS is similar to triangle. Now we got to match Q. Q matches with T. R matches with V. and S matches with W. And the reason they are similar, we use the shortcut of side, side, side. Okay, let's try example F. We're going to do a 2-column proof to see if we can prove that these two triangles here are similar. ABC, so ABC similar to DBE. Remember, in 2-column proofs, you always want to start with something given and then build from there. So the first thing I notice that's given, besides the measurements, is that AC and ED are parallel. So I'm just mark this a little better. So I'm going to write that down. So AC is parallel to ED. And the reason for this is given. So now I want to try to use this to get my next statement. And remember, what we're trying to do is use one of these shortcuts. So I either want to get an angle congruent with this statement, or I want to get some sides proportional. But if you recall, anytime you have parallel lines, I told you, it's probably going to give you an angle congruent, because we can use alternate interior angles, corresponding angles, all that good stuff. So let's see if we can find some angles congruent. So because these are parallel, what you should notice is that angle C and angle E, we could actually say these are congruent because of this idea. If this is parallel, I have my transversal. If I erase the lines you don't need, you should notice that you have alternate interior angles here. So I can now say angle C is congruent to angle E. And the reason, because of the parallel lines, this is alternate interior angles. All right? So if you look, this has just given me an angle set. So if I'm looking at my shortcuts, that says I'm well on my way to using, I just need one more angle for angle, or I could use 2 more sides fractions for side angle side. But my best bet is angle. I just need to find one more angle set and I am done. So if you remember proofs, my next thing is I need to find one more angle set. So if you look, we have the bow tie. The very famous bow tie. I can put these angles congruent because it is vertical angles. So I just have to write that down. Step 3. Angle ABC. We need 3 letters. Angle ABC is congruent to angle DBE. So DBE. And the reason behind this is because we've seen vertical angles. So vertical angles. And now I have found my second angle set, which means I have a shortcut. I can now say these 2 triangles are similar, because I do have enough information, so I got to write my similarity statement, which is pretty much up here. ABC similar to DBE. So we're going to write that. Triangle ABC similar to triangle DBE. And the reason is our shortcut. We used angle similarity. All right, and that's your two-column proof for similar using shortcut angle. All right, one more example, and then I want you to try angle H, or example H by yourself, but we'll try example G. So remember, when you have overlapping, we want to write them apart. We also know these are already similar, so I'm just going to redraw them apart. So we'll go small triangle, big triangle. Let's go ahead and label these. This is G to P. Here's N. This is G to T. And this is S. We also are going to write in our information. So from N to P, we know this is 15. We also know S to T is 24. We know angle S, which is this guy, is 38. So we'll put a little 38 degrees in here. Okay, and then we also know from G to T is 20. Okay, so our goal is, first we want to find angle G and P. So G and P. We are trying to figure out this angle. Because these are similar, what you have to remember is one of the properties. Similar triangles or similar figures, matching angles, corresponding angles should be congruent. So that means these two angles are equal, which means if angle S is 38, then angle G and P should be equal to 38. That simple. Now, we are going to try to figure out GP. So if you look, GP is here. I'm going to label that as X because we don't know what it is. But see if we can figure this out. One of the properties of similar figures is that their sides, we can put them into fractions and put them equal to each other. So let's try that. I'm going to do GP, which matches with GT. So GP matches with GT, and it's going to be X over 20. Okay, and now I'm going to set up another ratio, which is going to be NP over ST. And that's going to give me 15 over 24. So in similar figures, these two fractions I can put equal to each other. They're proportional. So I can now say X over 20 is equal to 15 over 24. And we do multiply butterfly, cross multiply. So X times 24. And then we do 20 times 15. This equals 300, and to solve for X, we're going to divide by 24. 300 divided by 24 is 12.5. And we know that X actually represents GP because that's what we labeled it. So GP is 12.5. Okay, go ahead and solve for ST and example H, and we'll go on from there. Okay, so in example H, hopefully you tried it. Let me just explain something. I split these apart, and here's the key to this. We're trying to find ST, which is from here to here. But when we split it apart, there is no ST. What we do have is R to T. So from R to T, from here all the way here, is actually going to be 10 plus X. And if we can solve for X, we can solve for ST. Okay, so to solve, we do the matching game again. 10 over 10 plus x, these match. So RS over RT. So 10 over 10 plus x equal to another fraction. We match again, and that's going to be 8 over 12. Once we have a proportion, cross multiply and solve.